This video is a continuation of my high-powered antenna tuning unit. I'm now ready to do some tests on it. So I've hooked it up to my system here. I've got a small HF transceiver, 706 there, feeding a linear amplifier, and the linear is feeding the high-powered tuner, and the tuner is going off to the antenna or a dummy load. So before I turn it on, I've put some little bits of tape over the LEDs. They tend to affect the camera, so I've had to reduce the brightness. So here we go, I'll turn it on. First thing it's going to do is go to the last memory that was written, which in this case is memory number, let's have a look here, it'll come up on the display, memory number 7, which I had set up for 7.19 megahertz, and you would have seen the two tuning capacitors go to 0. I'll just do that again. They reset themselves to 0. 0 marks are just here, and that particular amount is at what's called an offset to compensate for the position of the micro switch. So that has now gone to the settings that I had found for tuning the 40-80 meter trap dipole to 7.2 megahertz for minimum SWR. So zooming in on the display, the amount of inductance was 2, and the second LED is turned on, and 490 on the capacitor, input capacitor, and 630 on the output capacitor. That is 490 of 800. 800 is the full amount of capacitance, and 1 is the least amount. Here we have a couple of meters, analog meters, for forward power coming from an internal Stockton bridge in the device, and standing wave. I also have a position here for phase. What that does, there's a phase discriminator in line as well. They're normally designed for center 0 meter. I don't have a center 0 meter, so I'm using this meter as phase 1 and this meter as phase 2. When the two needles are exactly the same, we know that the voltage and current at that point in the instrument, as seen looking at the coax, is they're in phase. If they're out of phase, one needle will read higher than the other. The direction of which needle reads higher tells you whether to increase or decrease the amount of capacitance or whatever it is you're adjusting. Now I'm switched to dummy load. I've got a switch here which switches dummy load in or out. The dummy load can handle 400 watts. That's bypassing the tuner. That's the tuner in circuit, and that's the dummy load. I've set the IC706 for 10 watts output, and you'll see that on the analog meter. You'll see there's no SWR because of the dummy load. On phase, both needles go to the same position. Okay, I'll just set it to the 100 watt mode, and you'll see the needle is only going to 10 on that display. I'll just go in a little bit closer. So we're running 10 watts into dummy load. So I'm going to go down to 3.550 megahertz, near the bottom end of 80 meters, and I'm going to show you what the standing wave is without the tuner in circuit first. So here we go, 10 watts. It's not that high, it's about 1.5 to 1. I'm going to reduce that to a lower value. So I'm going to demonstrate the tuning the dipole on 3.55 megs, but first thing I'll do is I'll use the memory down button, and I'll go to one of the memories which I know I've pre-programmed at 3.55 megs. That happens to be memory 1. Okay, so I'll just hit the right button because that'll be the last memory written, and what I'll do, I'll start the system up. I'll go and read whatever values I've got in there. I'll just move the camera, and by hitting the reset button or the memory read, either will do it, you'll see the capacitors go to the positions I'd found before, and it should be set up. So the tuner's in, so I'll just see what the SWR is, and you can see it's nothing. If I take the tuner out of circuit, you'll see it's 1.5 to 1. Now I'll go back into circuit, and what I'll do, I'll adjust the inductor. I can do that by putting this switch in the inductor position. You'll see these LEDs move up and down. And what I'll do, I'll transmit while that's happening, and you'll see the SWR go up. The inductance has gone to 10, and it shoots up a bit at 8, then goes back down. And the idea with these tuners is you try and use the least amount of inductance possible, and that happens to be 7. Now I'm ready to tune the capacitance. I'll try the output capacitor first. I can use the little knob here, and it only moves a small amount, very fine control, or I can use the step up button or the step down button. You can see SWR go up and down. It reaches the minimum. C in, I can adjust that as well. Sometimes you get a little bit better. There we go. You can fiddle around a bit more, go back to C out. Maybe I can improve it. It's just under 1.5 to 1. Now if I record that, record it, and then I memory read, it'll go to those new values. There we go. Inductance is actually 7 now. These will change. When I first recorded it was on a wet night, so the values would be slightly different. There we go. It's actually about 1.4 to 1. You can do it probably a bit better if I play a bit more.